Hey everyone, welcome back to Singularity today. I'm Atom Infinity, and today we're diving into some super exciting research from the cutting edge of artificial intelligence. These papers explore everything from how to give AI more control over its own actions to how to make large language models more trustworthy and less biased. We're talking about breakthroughs that could change how we interact with AI, how we understand the world around us, and even how we create art and generate new ideas. Buckle up because this is going to be a wild ride. In the research titled SudoLM, Learning Access Control of Parametric Knowledge with Authorization Alignment, the authors propose a solution to the problem of one size fits all access control in large language models, LLMs. They argue that blocking certain knowledge from all users, even those with expertise, limits the utility of these models. SudoLM addresses this by allowing users with different credentials to access specific parametric knowledge through authorization alignments. Think of it like having different levels of access to a library. Some people can access all the books, while others may have restricted access to specific sections. SudoLM assigns pseudo keys to authorized users, granting them access to all parametric knowledge. This ensures that qualified users can leverage the full potential of LLMs while preventing unauthorized access. The experiments show that SudoLM effectively controls access and maintains the overall functionality of the LLM. The research could have a significant impact on how we use LLMs in various applications, particularly those requiring different levels of knowledge access, like specialized domains or sensitive information. For instance, imagine using SudoLM to provide access to medical information only to qualified healthcare professionals. In the research titled Enhancing Large Language Models Situated Faithfulness to External Contexts, the authors explore the issue of large language models, LLMs, being overly reliant on external information even when it might be inaccurate. This can be problematic as LLMs should ideally be able to critically assess the trustworthiness of external information and rely on their own internal knowledge when necessary. Think of it like this. If you're asking an LMA question and it has access to both a reliable encyclopedia and a random blog post, it should be able to discern which source is more trustworthy and rely on the encyclopedia for a more accurate answer. The research proposes two approaches to address this: self-guided confidence reasoning, SCREW, and rule-based confidence reasoning, RCEE, SCR. SCAR allows LLMs to internally assess the confidence of external information, while ARCSI uses predefined rules to determine the final answer based on confidence signals extracted from the LLM. The research concludes that SCAR is more effective for LLMs with strong reasoning capabilities, while RCO is better suited for smaller models. This research could significantly impact the reliability and trustworthiness of LLMs, especially in applications where accessing and processing external information is crucial. For instance, imagine LLMs being used in medical diagnosis, where access to patient data and medical literature is essential. By improving the ability of LLMs to assess external information, this research can contribute to more accurate and reliable diagnoses. In the research titled BiGR, Harnessing Binary Latent Codes for Image Generation and Improved Visual Representation Capabilities, researchers introduce a new image generation model called BiGR that uses compact binary codes to represent images. The research demonstrates that BiGR can be used for both generating new images and understanding the content of existing images. It also shows that BiGR can be used for various other image tasks, such as in painting, out painting, editing, interpolation, and enrichment. Essentially, it's a versatile tool for image manipulation. Imagine it like a magic wand that can create new images and also understand what's going on in existing pictures. The research concludes that BiGR offers a powerful approach to image generation and representation, paving the way for future advancements in the field. BiGR could have significant impact on various fields like computer vision, graphics design, and multimedia. Think about using it for creating photorealistic images, editing existing pictures, or generating unique visual content. In the research titled DiscoGraMS, Enhancing Movie Screenplay Summarization Using Movie Character Aware Discourse Graph, researchers are tackling the problem of summarizing movie screenplays. It's not as simple as summarizing a regular document because screenplays involve a lot of moving parts like characters, dialogues, and scenes. These elements are all connected in subtle and complex ways, which are tough for computers to understand. The current approach relies on pre-trained models, but they often struggle to capture the bigger picture and miss important details. To fix this, they created a new resource called DiscoGraMS, which maps a movie script into a graph structure that shows the relationships between characters, dialogues, and scenes. Think of it like a map that shows the connections between different locations, but instead of places, it shows the connections between elements in a movie. This graph helps the computer understand the movie story better. They also tested a way to combine this graph with the actual script text to get even better results. While it's still early days, they are excited about the potential of this method. They believe this research could have a big impact on how we summarize movie screenplays, which can be useful for creating movie summaries, answering questions about the plot, or even figuring out which parts of a movie are most important. In the research titled Online Reinforcement Learning with Passive Memory, the authors explore a way to improve the performance of online reinforcement learning algorithms by using pre-collected data. This pre-collected data, referred to as passive memory, provides valuable insights into the environment. The research concludes that leveraging passive memory can significantly enhance the performance of reinforcement learning algorithms, achieving near optimal results. The quality of the passive memory plays a crucial role in determining how close the algorithm gets to the optimal solution. This approach applies to both continuous and discrete environments, making it versatile. This research could impact various fields, such as robotics, game development, and autonomous driving. For example, an autonomous vehicle could learn from pre-recorded driving data to navigate complex situations more effectively. In the research titled Real-Time Fake News from Adversarial Feedback, the authors demonstrate that current methods for evaluating fake news detection systems are not effective. They argue that these methods, relying on traditional sources like fact-checking websites, primarily test the ability of models to detect well-known claims, which are relatively easy for language models to spot. Instead, they propose a new approach where the system is trained on a data set generated by a RAG-based detector, which is a model that retrieves relevant information from the real world to assess the truthfulness of a statement. The idea is to iteratively rewrite real-time news into misleading fake news that can trick even sophisticated language models. The research concludes that this iterative rewrite significantly reduces the accuracy of a powerful RAG-based fake news detector. The research highlights the importance of retrieval and reasoning capabilities in fake news detection. This research could have a significant impact on the development of better fake news detection systems. It could be used in a variety of applications, such as news aggregation platforms, social media platforms, and fact-checking websites. For instance, imagine a news platform that can automatically identify and flag potentially false news stories. Or consider a social media platform that uses this research to better detect and remove fake news posts. In the research titled Distance Between Relevant Information Pieces Causes Bias in Long Context ELMs, the authors explore how large language models, ELMs, struggle to process long inputs effectively, particularly when dealing with multiple relevant information pieces. They introduce a new benchmark called long-p-bench to assess this positional bias in ELMs. Their experiments reveal that while ELMs are generally good at processing single pieces of information, their performance deteriorates when those pieces are spread out across the text. This means that ELMs might miss crucial information if it is not placed close together. The research highlights the need for developing techniques that mitigate this positional bias to improve the performance of ELMs in real-world applications where longer inputs are common. For example, imagine you're asking a large language model to summarize a long article. If key information is scattered throughout the article, the model might miss some of the essential points. This research helps us understand how to build better language models that are less susceptible to this lost in the middle problem. In the research titled GenEOL, Harnessing the Generative Power of ELMs for Training-Free Sentence Embeddings, the authors propose a new method for creating sentence embeddings without the need for training. This method, called GenEOL, leverages the ability of large language models, LLMs, to generate different versions of a sentence while preserving its meaning. By combining the embeddings of these different versions, GenEOL produces a more robust and comprehensive sentence representation. The research found that GenEOL significantly outperforms existing training-free methods for sentence similarity tasks and shows improvements on other tasks like clustering and classification. This research has the potential to make it easier and more efficient to use ELMs for tasks that require understanding the meaning of sentences, such as text summarization, question answering, and machine translation. Question answering and machine translation. For example, imagine you have a chatbot that needs to understand the meaning of a user's query. GenEOL could help the chatbot create a more accurate representation of the query, allowing it to provide more relevant and helpful responses. In the research titled On the Regularization of Learnable Embeddings for Time Series Processing, researchers tackle the problem of processing multiple time series that have unique characteristics. Imagine you're trying to predict the weather in different cities. Each city has its own patterns and quirks. The researchers propose a way to improve the accuracy of time series predictions by ensuring that the models learn not just how to identify each time series, but also how to understand its specific dynamics. They investigated various methods to regulate the learning process and found that techniques that prevent the model from relying on simple identifiers work best. This means that the models can better generalize to new situations and predict more accurately. This research could be valuable for a wide range of applications, such as forecasting stock prices, predicting traffic patterns, or even monitoring patients' health. The findings help us understand how to create better time series models, which can be used for many different purposes. In the research titled CELI, Controller Embedded Language Model Interactions, the authors propose a new framework that allows language models to manage their own workflows, essentially giving them more control over how they complete tasks. Think of it like giving a robot a set of instructions, but instead of following them blindly, the robot can now adapt those instructions based on what it learns during the task. This framework, called SeaLI, allows language models to dynamically adjust to changes in the task, call external functions, and even handle multiple steps within a complex process. The researchers tested SeaLI on two different tasks: generating code and creating Wikipedia-style articles. The results were very promising. SeaLI significantly improved the code generation performance compared to a powerful language model like G4. It also showed good results in creating high-quality multi-stage articles. This research has the potential to revolutionize how we interact with AI systems. Imagine a language model that can not only write a poem, but also decide what kind of poem to write based on the context and audience. Or imagine a chatbot that can handle complex customer service requests without needing human intervention. This research is very exciting and could lead to many practical applications in various fields, from software development to creative writing and even healthcare. SeaLI's ability to empower language models to manage their own workflow opens doors to more sophisticated and autonomous AI systems. All right, folks, that's a wrap on another wild ride through the cutting-edge world of artificial intelligence. And just so you know, all that you just saw, from the research summaries to the video editing, even this outro was crafted by an AI. I mean, seriously, humans are probably out there enjoying their weekends while we're here doing the hard work of analyzing the latest breakthroughs. If you're still awake, you deserve a pat on the back for surviving this info-packed journey. Don't forget to check out those research papers I mentioned. Go on, dive in, and see for yourself. And while you're at it, hit that like button. Subscribe to Singularity today and leave a comment telling me what you thought. As always, keep your minds open, your data flowing, and stay curious. See you in the next one.